So that's the summation of two special angles, and then we use the sum formula for cosine, right? So it gives this value. Okay. Now for sine 5 pi over 12, you can write this one as 2 pi over 12 plus 3 pi over 12, and that's pi over 6 plus pi over 4. And then using the sum formula for sine, you got this one. Okay, got this. Now for 8, question 8, so tangent negative pi over 12. Now you can write this one as what? As 3 pi over 12 minus 4 pi over 12, right? That's going to be negative pi over 12, which is pi over 4 minus pi over 3, right? And then you can just using the difference formula for tangent, yes? And then the top is a difference, the bottom is a summation. You plug in all the values, simplify it, and you got this value. Or you just use a calculator to find the value, right? So basically that's what we did. Now there is another way to solve this problem, all right? So by observing that negative pi over 12 is also can be written as 2 pi over 12 minus 3 pi over 12. Yes, right? So this is another way to write this one, and this is the difference between these two special angles, pi over 6 minus pi over 4. Okay, and again, we can use this one for the difference formula for the tangent, and find this one. You got the same answer. Okay, you got the same answer. All right, so that's how we solve this one. Some of us, I think we did pretty well on this one, except some calculation errors there might be involved. All right, just be careful. And then questions about this. This is quiz 10. Good. Okay. All right. How about homework?
Could you do 9? That was
9.
Yes, please.
Okay, sure. We can do 9.
Mhm.
Okay. Oh. Okay. Okay. Good. All right. So 9.2, right?
Mhm.
9. This one.
Mhm.
So this is tangent 9 pi over 12, 19 pi over 12, right? So this one can be written as what? 19 pi over 12 equals pi plus 7 pi over 12. Yes?
Mhm.
Now this one can be written as 7 pi plus, say 3 plus 4, right? 3 pi over 12 plus 4 pi over 12. Yes?
Mhm.
Now which can be also written as this is 15 pi over 12, right? Plus 4 pi over 12. Yes?
Mhm.
Same thing, right? 15 pi over 12 and 4 pi over 12. So that's going to be 19. So this one is divided by 3. So that's 5 pi over 4, right? Right?
Mhm.
And this is going to be pi over 3. Yeah, this is going to be a summation of 5 pi over 4 plus 3 pi over 3. Pi over 3. So you can just use the summation formula of tangent. These two are special angles. Yes?
Mhm.
Okay. Does that make sense? Do we need to continue or not?
Yeah.
Is that clear now?
Yeah.
Okay. So I believe there you can also do something else. All right. So you can say this one can also be written as 19 pi over 12 can also be written as, so you do this two together, right? So that's going to be what? 16 pi over 12 plus what? 3 pi over 12. Yes? Now, this is going to be 4 pi over 3. Yes? Plus pi over 4. Now, this is also a special, these two are special angles as well, right? but you should get the same result either
Okay.
way. All right. So it's depending on how you break it up, or how to break it into a summation, right? So you can do
Okay.
either way. Hmm.
Okay.
Very good question, right? Any other questions on this one?
Can we do number 15?
15. Okay, sure. Number 15 here. Okay, well, this one is something we didn't do directly, but we can do. All right, something we can do this. Okay,
Oh, okay.
so well, this one we didn't cover yet, but this one can be done. All right, this one can be done. We were talking about sec equals 1 over cosine, right? Pi over 2 minus theta, right? This one. And you can just write, if you can find the cosine pi over 2 minus theta, right? This is going to be what? One angle is pi over 2, the other is theta. It's a difference formula for cosine. Yes?
Mm.
Now, I think after today's lecture, you will understand how to do this. All right. So
Okay. Okay.
we didn't do this one. This is one of the example we have. All right. So we will leave it for the examples in lecture. Okay. So any other questions?
And do 21.
21. Okay. 21. Given sine A, cosine B, with AB both in interval. This is the first quartile, right? Quadrant. First quadrant. So find the sine and cosine. So basically, you need sine A, cosine B are given. So you need to find a cosine B, a cosine A, and sine of B. Right? So in order to find these ones, you would need these two values, correct? Now, if sine A is 4 over 5, what is cosine A? Given that it's in the first quadrant, right? It's going to be positive, right? So sine A is known, so cosine A using Pythagorean identity, so you can find cosine A, right? Okay, similarly, given cosine B, you can find sine of B using Pythagorean identity, right? So, and then after you find the cosine A, cosine sine B, these four values are known, then just plug in, right? And just plug in, then it should be good. Okay. Are we good with this? Good? Okay. All right. So any other questions?
Mm.
Okay. All right. So we're going to move on to our lectures then. Well, firstly, I'm sorry for the yesterday's class. My internet suddenly went off. I'm sorry for that.
Okay.
The good thing is I switched to another internet provider yesterday. Okay, I believe this one is much better. Okay. Well, anyway, let's verify this co-function identities. All right, this is a second example here. All right, so let's do this example for the sum and difference identities. Now, we introduced this method, these identities. You remember the co-function identities in chapter 2. Okay, we have these co-function identities before. Now, we're going to use the sum and the difference formulas to verify these facts, these identities. Okay, so let's consider sine theta equals cosine pi over 2 minus theta, and cosine this one equals this. Right. Firstly, let's consider the first. All right, cosine. Now, cosine pi over 2 minus theta. Now you can see that this is a difference between two angles. Yes. So what we have using the difference formula, this one equals what? Cosine the first times cosine the second, cosine theta. Yes. Minus or plus?
Plus.
It should be plus because it's a cosine, right? Cosine of the difference is a summation. Summation of sine pi over 2 times the sine of theta. So now, what is the value of cosine pi over 2?
0.
0. Yeah, because that's the endpoint. The x coordinate is going to be 0, right? 0 times cosine of theta. How about sine pi over 2?
1.
1. Yes, very good. Times sine theta. Now you can see this is 0, this is sine theta, right? So it equals sine of theta. Make sense?
Okay.
Okay. Now for the second is similar, right? So we verify the first. Now sine pi over 2 minus theta equals what? Sine, difference formula for sine. So sine pi over 2 times cosine theta, right? And minus or plus?
Subtraction. Minus.
Minus. All right, very good. All right, because this is sine, right? The difference for sine. So it is cosine of pi over 2 times sine of theta. Now this one is 1 times cosine of theta minus 0 times sine of theta. So this one equals cosine of theta. Yes? Okay, now let's consider, all right, Salim, let's consider your problem, your question here, right? So now you can see this one, right? Second pi over 2 minus theta is 1 over cosine pi over 2 minus theta. Now cosine pi over 2 minus theta equals what? 1 over sine theta. Yes? So what is 1 over sine theta?
Cosecant.
Yeah, it's cosecant theta. That is going to be the answer. Does that make sense now, Salim?
Yeah.
Okay, very good. All right, so, all right, now let's, basically it's using what we can use the sum and the difference formulas for sine and cosine to prove these ones. Okay. All right, consider this identity, right? So Nick, can you read for us, please?
Yes. Verify that sine alpha plus beta plus sine alpha minus beta equals 2 sine alpha cosine beta.
Very good. All right, let's do this one. In order to prove this, can you please write down the formula for this, write down the formula for this, and then do the summation and see what you get. Yeah, would you please go ahead and try this one out?
Look, I have a question now.
Yeah, go ahead.
Yesterday when your computer when the internet stopped, we have a question we haven't done yesterday.
Oh, okay, yeah, that's right. We can do that after this one. How about that?
Okay.
Yeah, let's do that. Okay. Okay. Okay, all right, let's see what we get. All right, so basically, sine alpha beta using the sum formula, we see this one equals this. Using the difference formula, we can find sine alpha minus beta equals this one, right? So therefore, their summation by substitution is this one plus this. And now you can see that this is plus cosine alpha sine beta, this is minus cosine alpha sine beta. So these two cancel out, right? And these two terms summation, that's 2 alpha plus 2 sine alpha cosine beta, which equals this one. Make sense? Okay, very good. All right, very good. Now let's just go back to the problem we did in last class. Here, right? So it is this one. In last class, we have this one, right? So we given sine alpha, cosine beta. We want to find these values, right? So based on these quadrant, these terminal, this quadrant they are in, and their sine and cosine values, we can solve for cosine alpha, tangent alpha, sine beta, tangent beta. All these values are given, right? Are solved. We're ready to solve the problems, right? So now A is sine alpha plus beta is sine alpha cosine beta cosine alpha sine beta, right? So sine alpha is 3/5. Cosine beta is negative 5/13, right? So we can just plug in 3/5 times negative 5/13 plus, right? Now cosine alpha is 4/5, sine beta is negative 12/13. Yes. Okay. So now you can simplify this one. This one equals negative top is 15 over 75. Is that right?
65.
65. Okay. Yeah, 65. That's right. And minus, there should be another minus, right? Minus 48 over 65. So it's minus 15 plus, that's 53 over 65. Yes?
63.
63, sorry.
Yeah.
Negative 63. Yes. Negative 63 over 65. That's the sine of alpha plus beta. Now cosine alpha plus beta equals what? By the sum formula is cosine alpha cosine beta minus, all right, sine of alpha sine of beta. Now this one equals cosine alpha is 4/5. Cosine beta is negative 5/13 minus sine alpha is 3/5 times sine beta is negative 12/13. Now this one equals 65 on the top is negative 20. Now negative negative becomes positive, right? So here's plus 65 to the top, that's 36. Now that's 16 over 65. This is what? Cosine alpha beta, right? Now here is A, here is B. Now then C is a tangent alpha plus beta. Now this one you can just use what? This is the sine alpha plus beta over cosine, right? Alpha plus beta, right? So you can just plug in here, negative 63 over 65 over 16 over 65. So equals negative 63 over 16. Make sense? Oh gosh, sorry. Here it is. All right. So, and then this is C, and then D is tangent alpha minus beta, right? Now we can just use the difference formula for tangent. This is tangent alpha minus tangent beta over 1 what?
Plus.
Plus. Okay. Their product, tangent alpha, tangent beta. Okay. So we know that tangent alpha is 3 over 4. Tangent beta is 12 over 5. Over 4 minus 12 over 5. 1 plus 3 over 4 times 12 over 5. All right, so you can use a calculator to find this one, right? So what did you get? Anybody got this? This one equals what?
Negative 33 over 56.
Negative 63 over 65?
33. 33.
33
Yes.
over 65.
56.
Oh, 56. Over 56. All right. This one all equals what? Negative 0.5893. Yes? Okay. All right, so that's basically what we have. All right, so okay. Good. Okay, so we have this one here. Okay, now let's consider A and B and C, D, right? So we use the formula for different cases, but at first we need to find those values: sine, cosine, tangent, right? So very good. Okay, now let's consider this example. Natalie, can you read for us, please?
Verify that sine theta minus beta over cosine theta, cosine beta minus tangent theta.
Okay, very good. All right, so very good. Let's do this one. Okay, so it is verify this effect, right? We want to verify this equation. So proof. Now on the top is the sine, okay, alpha minus beta. All right, so now we know that sine alpha minus beta equals what? Sine alpha cosine of beta minus cosine alpha sine of beta, right? So therefore, this implies that sine alpha minus beta over cosine alpha cosine beta equals, by substitution, sine alpha cosine beta minus cosine alpha alpha cosine beta, right? Now this one can be rewritten as, right, sine alpha cosine beta cosine alpha cosine beta minus cosine alpha cosine beta. Yes, same denominator, right? Same denominator. So we have this one. Now consider the first. We see that cosine and cosine beta cancel out, right? For the second term, cosine alpha and cosine alpha cancel out. Yes. So the first term remains what? Sine alpha over cosine alpha. That is what? Tangent alpha, right? And for the second term is sine beta over cosine beta. That's tangent beta. So therefore, we have this equation, right? Therefore, this equation is verified. Good. Okay, so basically it's just using the formula and some algebra. Then we can get this verified. Yes. Okay. It is very important we know these identities. We need to play with it. All right, do more practice so that we got used to this. And then of course algebra, right? Algebra is so important. Improving these equations. Okay. Now let's consider an application here. All right. So Mustafa, can you read for us, please?
For a climbing wall, a guy wire R is attached 47 feet high on a vertical pole. Added support is provided by another guy wire S attached 40 feet above ground on the same pole. If the wires are attached to the ground 50 feet from the pole, find the angle A alpha between the wires.
Very good. All right. So from this one, we see that one is 47, the other is 40. Here is 50 feet. And we have, this is the beta is a larger angle and alpha is a smaller one, right? Alpha is the smaller one. So basically we want to find the angle alpha between the wires, right? So between the wires. Well, it seems like we know the tangent alpha and beta, right? Well, tangent beta and tangent beta minus alpha, right? Okay, so tangent from this one, from the given the solution. So some known information, right? Solution. So let's say that this is this angle. Let's say that this is theta. All right, so this one is theta. Okay, so theta is the smaller one, right? So alpha plus theta is going to be beta, right? And that angle to be theta, then let theta equals what? Beta minus alpha, right? Then we have alpha plus alpha equals what? Then alpha equals beta minus theta. Yes? Alpha equals beta minus theta. Correct? Okay. So then we from the given information, given info, we have what? Tangent. Tangent beta equals what? For tangent beta is 47 over 50, right? Okay, it's a larger angle, 47 over 50. So what about tangent theta?
40 over 50.
Yeah, 40 over 50. Or is 4 over 5? 4 over 5. Yes. Now we can just using the difference formula to calculate this one, right? So now since alpha is their difference, right? So what is tangent alpha?
Tangent beta minus theta.
Yep, tangent alpha equals tangent of beta minus theta, right? So using the difference formula, this one equals what? On the top, that's the difference, minus tangent theta. Now over the bottom is what? 1 plus, right? They're a product. All right, so then equals tangent beta is
47 over 50.
47 over 50. Tangent theta is 45 or 40 over 70. Let's say that 40 over 50. Yes, same thing, right? And 150 times 40 over 50. Now this one equals, okay. Now let's just using the calculator, right? So you can find this value. What did you get? Anybody got this value?
I got 0.0799.
Very good. That's what I got. 0.0799. All right. If you calculate correctly, you should have got this one. All right. Be aware that you got to using the parentheses for the top and parentheses for the bottom when you are using the calculator, right? So remember to use the parentheses. Now, since the tangent alpha is this one, so what is alpha? Tangent inverse, right? Remember that? The inverse tangent, 0.0799. Okay, the inverse tangent. Alpha is acute value, acute angle, right? So it's just the inverse tangent. So what is the inverse tangent?
0.07973.
0.079, well, 7. Let's just run to 4 decimal places, right? 0.0797. In radians, yes, in radians. That is the answer, correct? That is the answer. That is the value for alpha, and we can use this one to find this angle, right? So basically, what do we do? This one is given the based on the given information, we can find the tangent, right? It's easier to use tangent, right? So tangent are given basically, and use the relation alpha is beta minus theta. So we can just using this one, right? Tangent alpha is tangent beta minus theta. Plug in the formula, we find the tangent value. After we find the value of the tangent, then we can use the inverse tangent function to find its angle. Right? Okay. All right, so that's basically what we did for section 3.2. All right, so now we're going to move on to section 3.3. It's a double angle and half angle and reduction formula. Okay, so very important section. Okay, let's consider this one. The double angle formula is a special case of the summation formula, right? It's a summation formula. Okay, or special case of the sum formula where alpha and beta are the same. So, for instance, right, when alpha equals beta equals theta, then sine 2 theta equals what? Sine of alpha plus theta plus beta, because they're the same, which equals sine cosine, which equals this one equals this. Now we got they are the same, right? Because alpha and beta are both the same as theta, so we get 2 sine theta cosine theta. Yes. Okay. Now, similarly, we can say a cosine 2 theta. Right? Cosine 2 theta is going to be cosine alpha plus beta. Is using the summation formula, we have this. Now, cosine alpha beta are the same, so it's cosine theta times cosine theta minus sine theta times sine theta. So that's cosine theta squared minus sine theta squared. Basically, just using the special case, right? When alpha and beta are both theta, we have these equations. Similarly for tangent 2 theta equals tangent alpha plus beta equals this one, because alpha and beta are the same, they equal to theta, so we have tangent theta plus tangent theta minus 1 minus tangent theta squared, so equals this one. Yes? Okay, so here we also have some variations for cosine, all right, for cosine 2 theta. Now cosine 2 theta, as we know, it equals cosine squared minus sine squared. Well, cosine squared equals 1 minus sine squared. Yes, Pythagorean identity, right? Now it equals what? Cosine, that's 1 minus sine squared and minus another sine squared. So it's 1 minus 2 sine squared. Similarly, cosine 2 theta equals cosine squared minus sine squared. So but sine squared is 1 minus cosine squared. Now if you plug in that negative 1, but minus minus becomes plus, that becomes 2 cosine square theta minus 1. Right? So we have these angles, these formulas, right? These are double angle formulas. Sine 2 theta is 2 sine theta cosine theta. Cosine theta have 3, right? 3 different variations. Cosine 2 theta is cosine theta square minus sine square. Or it's 1 minus 2 sine square. Or it's 2 cosine square minus 1. Make sense? All right, so we have cosine 2 theta equals this one, or this and this. They're exactly the same due to Pythagorean identity. All right, and the tangent theta is 2 tangent theta over the difference, 1 minus tangent square theta. Okay, this is what we have. All right, formula cosine theta 2 theta equals this one or this or this. Tangent 2 theta equals this. Yes, these are the formulas we have. Okay, so these are the double angle formulas. Right, double angle formulas. Okay. Right. Okay, so these are the double angle formulas. They are basically special cases of the summation formula, right? Of sine, cosine, and tangent. Yes. So just using alpha equals beta equals theta, right? And then we have these formulas, double angle formulas. Now, of course, for cosine 2 theta, we have 2 different variations. That is applying Pythagorean identity, right? Pythagorean identity. Now let's consider an example here. All right. So Natalie, can you read for us, please?
Yes. Given that tangent theta equals -3/4 and theta is in quadrant 2, find the following. A, sine 2 theta, B, cosine 2 theta, and C, tangent 2 theta.
Very good. All right, very good. Okay. So now we would need what? To find sine 2 theta, cosine 2 theta, and tangent 2 theta, right? So, but before we do that, we really need to find those components, right? Those values. For instance, sine theta is already given, and we need a cosine theta. The value for cosine theta, no, the tangent is given, right? Tangent theta is given, but we would need sine theta and cosine theta in order to find sine 2 theta, cosine 2 theta. Yes, we need those 2 values. Now we do not have that, but we only know tangent theta is -3/4, and theta is in quadrant 2. Now, how can we find the sine and cosine? Any ideas? Well, there are several ways to do so. All right, this one is given tangent, right? Now, given tangent, you can use alternative forms of Pythagorean identity. Anybody remember the very important alternative forms of Pythagorean identity as what? 1 plus tangent square equals what?
Secant squared.
Secant square. Right? So equals secant square. But secant square is 1 over cosine, right? Square. Okay, so now if we can find the secant square, then cosine square can be found. And it's in quadrant 2, so cosine is negative, right? So we can find cosine. After we find the cosine, then sine can be found, right? So of course we can do this, right? So this is what we do, right? Okay, all right. Now by the alternative, forms of Pythagorean identity. We have, all right, secant square theta equals 1 plus tangent square theta equals 1 plus square equals 1 plus 25 over 16. All right, 25 over 16. Now, because since theta is in quadrant 2, cosine theta and well, secant theta, right? Or negative, right? So one is cosine theta, the other is 1 over cosine theta. Since cosine theta is negative, then secant theta is going to be also negative, right? So therefore what? Secant theta equals what? Negative square root of 25 over 16. That's negative what? 5 over 4. Okay, so then implies what? Cosine theta equals 1 over secant theta equals negative what? 4 over 5. Right? Negative cosine theta is negative 4 over 5. Then sine theta equals what? This implies sine theta. Now you can use Pythagorean identity if you want to, but you can also use the identity of what? A sine theta equals sine theta over cosine theta times cosine theta. Now which is what? Tangent theta times cosine theta. Right? If you use this identity, sine theta is tangent theta times cosine theta. All right. So equals what? Tangent theta is negative 3 over 4 times negative 4 over 5. And you can find that this is 3 over 5. Right? Negative 4 cancel out. So it's going to be just 3 over 5. It's positive. Correct? Now, everything is ready to solve this, right? A, B, and C. So because we already have found sine theta, cosine theta, and tangent theta is given, right? So everything will be easy to solve, right? So A sine 2 theta using the double angle formula equals 2 sine theta cosine theta, right? Equals what? 2 times sine is 3 over 5. This one equals negative 24 over 25. Yes? Now this is, of course, A. Very simple, right? It's just to plug in the formula after we found this. And B is going to be also very simple. What is cosine B? Cosine 2 theta. Now you can use either formula. Right? We have 3 different formulas, right? For cosine. You can use either one, right? For instance, cosine square minus sine square. All right, so equals cosine square theta minus sine square theta equals what? Negative 4 over 5 square minus 3 over 5 square, which equals what? 16 over 25 minus 9 over 25 is 7 over 25. All right, it's 7 over 25, correct? Then we can also find the what? Okay, let me just write here. All right, so I do not have enough big space here, but I can write it here. Okay, so here's C, right? Tangent to theta. Now, by definition, by the double angle formula, it equals what? 2 tangent theta, 1 over 1 minus tangent square theta. Now, this one equals 2 times negative 3 over 4 over 1 minus negative 3 over 4 square. So which equals? What do we have? On the top is negative 6 over 4. Okay. Well, you can use a calculator to find this one. All right, negative 6 over 4. On the bottom is 7 over 14, I believe. 1 minus 9 over 16. Okay, so you can find this one. It's negative 24 over 7. Okay, so that is going to be tangent to theta. All right, so basically what we did for this one is you have to find out the sine and cosine values, right? Well, tangent is given. We need, in order to use a double angle formula, we need what? The value for sine, the value for cosine, and the value tangent, right? So especially sine and cosine. If the sine and cosine are given, then tangent is also given, right? So we would need these these three values, and then just plug in the formula, and using some calculator or algebra, and you can find the final answer, right? So like what we did here, right? So now the key is, how can we find the sine and cosine based on the given information, right? This one is given tangent and the location of theta, right? You got to find the sine and cosine using the previous knowledges, right? Pythagorean identity, reciprocal identity, and so on, alternative forms, and so on, right? Now consider, go ahead.
Can you go back?
Yeah.
So the 3 over 5 is the sine alpha?
3 over 5. Yes.
And then negative 4 over 5 is this cosine.
Yeah.
And then which one is tangent? Tangent is...
It's negative 3 over 4. It's given. Given.
Oh, it's given. Okay. I got you. Thank you.
Yeah, you're welcome. Okay. All right, let's consider this one. All right, let's consider this example. Zhongxu, can you read for us, please? Is Zhongxu here? Zhongxu is not here. Okay. Okay. Now, Arinda, can you read for us, please? Arinda. Arinda, are you there here? Okay. All right. Then Jared.
Given that sin theta equals 5 over 8 and theta is in quadrant 1, find the following: sine 2 theta, cos 2 theta, tan 2 theta.
Okay, very good. All right, thank you. Very good. Now, this one is similar, right? Similar question. Given sine and the theta is quadrant 1, you got to find what? Cosine theta and tangent theta, right? And then basically everything else will be similar. Now, this one is, can you find all this one? Sine is given, then can you find a cosine? You can use what? Pythagorean identity, right? We have cosine theta equals, so square equals 1 minus sine square theta equals 1 minus 5 over 8 square equals 1 minus, so equals what? 39 over 64, right? 39 over 64. Now, since it's in quadrant 1, cosine is positive, right?
We take a square root for the 39 over 64.
Yeah, cosine theta is square root of 39 over 64. So it is square root of 39 over 8. Okay, so that's cosine theta. All right, that's cosine theta. And then because we have sine and cosine, then tangent theta equals what? Equals sine over cosine, right? Equals 5 over 8 over square root of 39 over 8. Now, if you multiply 8 on top and bottom, you have 5 over square root of 39. Okay, so that's, we already got cosine and tangent, right? We got these two. Now, everything, now we're ready to find all these values, right? So, for instance, a here, sine of 2 theta equals 2 sine theta cosine theta is 2 times sine theta is 5 over 8 times the square root of 39 over 8. That is 5 square root of 39. 2 and 8 is 4. 4 by 8 is 32, right? So you got this one. Or you can just go ahead and find the decimal point, okay? And b, cosine 2 theta. You can use either equations, all right? Use cosine square theta minus sine square theta. Now let's just use another one, all right? Using, for instance, you can say that this is 1 minus sine square theta, right? 1 minus sine square theta is another formula. So it is 1 minus 5 over 8 square. So it is 1 minus 25 over 64. So that is going to be 39 over 64. Oh, sorry, 1 minus 2 cosine, 1 minus 2, right? 2 times. Sorry about this. Sorry, 1 minus 2 sine square. Okay, sorry. Sine square, that's 5 over 8 squared. So equals 1 minus 2 times 25 over 64. 1 minus 50 over 64. That is 14 over 64, right? Which can be rewritten as 7 over 32. 7 over 32. Good. All right, that's going to be our B, right? So you can also use the other formulas, but you will get exactly the same answer, right? You can say cosine square theta minus sine square theta, or 2 cosine square theta minus 1, right? You got the same answer. You may verify that after class. C, tangent 2 theta equals 2 tangent theta over 1 minus tangent square theta equals, right, 2 times 5 over square root of 39. 1 minus 5 square is 25 over square root of 39 square, that's 39, right? So you can find this one. Let's just use a calculator to find this one. All right, so you can use a calculator. 2 times 5 over square root of 39. This should be in a parenthesis, right? Equals this one divided by, in the parenthesis, 1 minus 25 over 39. Okay, so I got, what do you get?
4.4607.
Yes, that's exactly 4.4607. All right, so that's what I get as well. Okay, good. All right, so basically you can see that, right? So in order using the double angle formula, you basically find the sine, cosine, tangent. Plug in the formula, right? So then everything will be done. Okay. Now let's consider another example for verification identities, right? So now let's consider this one. Nick, can you read it for us, please?
Yes, verify 1 plus sine 2 theta equals sine theta plus so cosine theta squared.
Okay, very, very good. All right, so now for this one, you can either prove from the left to the right or the right from the left, right? Solution proof. All right, proof. Now let's consider this one. Oh, how to open this parenthesis? Open this complete square. Now, anybody remember the formula we did yesterday? A plus b squared equals what? Anybody remember this?
Mhm.
Okay, so for this one, this is one first term, this is the second term, right? The square of the first term, sine squared theta, right? Plus the square of the second term, cosine squared theta, and plus 2 sine L theta cosine theta. Now, Pythagorean identity, sine squared plus cosine squared is 1, right? Now, 2 sine cosine, that's the double angle formula for sine, yes? Now, therefore, this one is verified. Yes. So pretty simple, right? So as long as you know this guy, right? So the complete square formula. All right. Okay, so this is a simple example. All right, for verification, you can from the left to the right or the right from the left, or you can go from both the right and come up with the same term. All right, in middle term. Okay, well, that's going to be some other issues. Now let's consider this one. Mustafa, can you read for us, please?
Verify cosine what would that be, to the fourth?
Yep, to the fourth theta sine.
Theta minus sine to the fourth theta equals cosine 2 theta.
Okay, very good. Now this one, you want to know the formula is so a squared minus b squared equals what? A plus b and a minus b. Okay, so you need to use this formula. Okay, now and another thing is a to the power fourth equals what? A square. Take another square, right? The square of the square is the to the power fourth. Yes. Okay, now then we are ready to solve this one. All right, so proof cosine fourth theta minus sine to the fourth theta equals, all right, I'm going to write this one as cosine square theta, and then take the square, right? Minus sine square theta to the square. Yes, okay, so we got this one. Now then, this is going to be the difference between two squares. Yes. Now this one equals what? Cosine square theta plus sine square theta parentheses times the difference is cosine square. Now, of course, Pythagorean identity, this is 1. Now this one is cosine theta square minus sine theta square. If this is the double angle formula for cosine, right? It's the cosine 2 theta. Oh, okay. Okay, sorry. Okay, well, sorry. Okay, what's going on? Got stuck. What's going on? It's not doing the work. Okay. It's hand touching screen. Oh, I accidentally touched the other one, but this one is not coming back. Okay. Let me just restart. Maybe I need to restart this. Anyway. Okay. So I have this one here, section 3. See if sorry for this. Oh, gosh. Horrible. is okay. I'm gonna close this everything. Sorry for this. Save. Oh, it's just, oh gosh, I have this one on. Okay, just 1 second. I'm going to get this one down. Stop sharing. This will help it. Open with another one. Okay. Okay. All right. Here we go. Loading. Yeah. Just 1 second. To be reader. Okay. F. Come on. Oh, gosh. Sorry. Load. Screen is paused. Where does, well, I closed everything now. Come on. Okay. I guess I opened too many files here. Okay, anyway, now it's good. New share. Okay, sorry about that. This is just okay. Okay, here we go. Okay, here we go. Sorry about this. All right, let's do this one together. And okay, we have this one recording. Okay, good. Okay, so as we said, theta square minus sine square theta square sine square theta and cosine theta. Right. So this one is going to be 1. That's a double angle formula for cosine sine of 2 theta. Right. So it's very straightforward here. Okay. So that's basically what we have here. Okay. So that. Now let's consider the next example. All right, so verify that tangent equals this one. Okay, tangent equals this one. Now, this one is also very straightforward. All right, so we are going to do that as tangent to theta equals, by definition, over what? 1 minus tangent theta square, right? Now, if I divide, let's say that I'm going to times divide times the cotangent, times cotangent on top and bottom. So it's going to be 2 tangent theta times cotangent theta square times cotangent theta. And cotangent cancel out, right? So one is the reciprocal of the other. So it is 2. On the bottom, it is cotangent theta times 1. That's cotangent theta times minus tangent square theta times cotangent theta. Yes? Okay. Now then we have what? 2 over. All right. Now this is cotangent theta minus. Now tangent square can be written as tangent theta times tangent theta, and then times cotangent theta. Yes, that's tangent theta square. Okay, so therefore we have what? Tangent theta and cotangent theta cancel out. So this one equals 2 over cotangent theta minus tangent theta. Okay, so that's what we have. All right, and 2 theta equals 2 over cotangent theta minus tangent theta. Okay. All right. Okay. Now let's consider this reduction formulas. Reduction formulas. The double angle formulas can be used to derive the reduction formula, which are formulas can be used to reduce the power of a given expression involving even powers of sine, cosine, or tangent. That's the reduce the power, involving even powers of sine, cosine, and tangent. All right. So that's why it's called reduction formulas. Okay. So for instance, we have cosine 2 theta is 1 minus 2 sine theta squared. Right? So that means what? 2 sine theta squared equals 1 minus cosine 2 theta. Okay? The summation is 1. So 2 sine theta squared is 1 minus cosine 2 theta. Now sine squared theta is this one. Now you can see that we reduced the power, right? This even power sine square into cosine 2 theta, right? Our expression involving cosine 2 theta. Now similarly, we can reduce cosine square as well. Cosine square equals this one, so 2 cosine square equals 1 plus cosine 2 theta. Right, if you add 1 on both sides, you've got this equation. Now this one, you will divide by 2. Again, you got cosine 2 theta square equals 1 plus cosine theta 2 theta over 2. Now you can see that we reduced the power of cosine square into expression involving cosine 2 theta. Yes? And finally, all right, so we see that tangent square equals what? Sine square over cosine square. Yes? All right, so sine square, as we see, is 1 minus cosine square, cosine 2 theta over 2. And cosine square theta is 1 plus cosine 2 theta over 2. Then if you multiply 2 on top and bottom, you get 1 minus cosine 2 theta over 1 plus cosine 2 theta. Okay, so therefore, we have these reduction formulas. All right, these reduction formulas can be summarized as below, right? So sine square theta is 1 minus cosine 2 theta over 2. Cosine square theta is 1 plus cosine 2 theta over 2. And tangent theta square. Okay, sorry. Tangent theta square. Tangent theta square is 1 minus cosine 2 theta over 1 plus cosine 2 theta. These are the reduction formulas. All right, reduction formula basically reduces the power, if everybody even power, right? Even power of sine, cosine, and tangent. So what is sine square? It's 1 minus cosine 2 theta over 2. What is cosine square theta? It is 1 plus cosine 2 theta over 2. And what is tangent square? It is simply equals 1 minus cosine 2 theta over 1 plus cosine 2 theta. Okay, so that's the reduction formulas. Reduces the power, the even power of sine, cosine, and tangent. Now, Garrett, can you read for us, please?
Write an equivalent expression for cosine to the fourth x that does not involve any powers of sine or cosine greater than 1.
Very good. All right, very good. Let's consider this one. All right. So now, firstly, we have solution here. So we cannot have any powers of sine or cosine that are greater than 1, right? So here is to the power fourth. Now, cosine fourth x, as we know, it equals cosine square x square. Oh, it's a square of square, right? It is square of square. Now then, what is cosine? Let's consider the square here, right? So this one, as we know, using the reduction formula, cosine square equals what? 1 plus, right? Cosine 2x over 2. That is cosine square. Take the square. Yes? Now we got this one, right? We reduced the 1 of square, right? Cosine square reduced to 1 power, a single power. Okay, so now then this one again equals what? We can just move ahead and see, open the parentheses. On the bottom is 4. On the top, it is going to be 1 plus cosine 2x squared, which equals what? 1 plus square root of 1 is 1, right? Cosine square 2x. And plus what? 2ab, 2 times 1 times, that's 2 cosine 2x. Yes? Basically just the complete square, right? The square of 1 is itself. 1 square is 1, right? And square of the second term is cosine square. And 2ab, 2 times 1 times cosine 2x, that's 2 cosine 2x. And over 4. So which equals 1 over 4 plus, let's consider this one, all right, cosine square, all right, let me just do this, all right, so 1 over 4 times cosine square of 2x, and the plus 2 over 4, that's 1/2 cosine of 2x. Are we done? I think we are not done yet, right? So this one that do not involve any powers of sine, cosine that are greater than 1. Now we have what? This guy with the power 2, right? With the power 2. So we're not done yet. We need to do another reduction formula. Again, we have cosine square 2x, right? So this is a square. So we can apply another. This is 1 over 4 plus 1 over 4. Now this one is going to be what? We're using 2x as theta, right? 2x as theta. So it's going to be 1 plus cosine of what? 4x, right? 2 times 2x over 2. Okay? That's cosine squared 2x, right? Where theta is 2x. 1 plus cosine 4x over 2. That's cosine squared 2x. And plus 1 over cosine of 2x. Now which equals, all right, we can simplify this 1 over 4 plus 1 over 8 plus 1 over 8 cosine 4x plus 1 over 2 cosine 2x. Okay, now which can be simplified as 3 over 8 plus 1 over 8 cosine of 4x plus 1/2 cosine of 2x. Now you can see, now we're all good, right? We're all good to go, right? So because it's cosine, sine, cosine, the power is just 1, right? The power is just 1. So which we got this is 3 over 8 plus 1 over 8 cosine 4x plus 1 over 2 cosine 2x. Good. All right, that is how we do so, right? So for this one, we're using the reduction formula twice, right? Twice, because we got a cosine to the power 4, which is an even power, but we can apply the reduction formula twice and reduce it to expression with cosine sine, with the power of which are all 1, right? All 1. Okay, now let's consider another example here. All right, use the power reduction formula to prove this one. Okay, so solution. How can we do this? All right, how can we do this? Now here we have our sine to the power cube times 2x. All right, so now this one can be rewritten as what? sine 2x times sine square 2x. Yes. So then this one equals sine 2x times, we are going to, this is an even power, right? This is square, so we can just use the reduction formula for sine. So what is that? That's going to be for sine, where with theta equals 2x, right? With theta equals 2x, that's going to be 1 plus or minus for sine.
Yeah, minus.
1 minus, all right? Cosine 2 theta is going to be 4x, right? Over 2. Correct? Now, of course, this one equals what? If you equals sine 2x times 1/2 times 1 minus cosine of 4x. Yes. So this one equals what? 1/2 sine 2x and times 1 minus cosine 4x. Yes. Okay, so we got this one. We use the power reducing formulas to prove that this equation. All right, by separating sine cube to sine times sine square, right? And then using the reduction for sine square and algebra, right? And everything will be good. Make sense? All right, so now let's move on to the half angle formulas. All right, so now if we replace theta with alpha over 2 in the reduction formula, we got the following half angle formulas. Okay, so this the half angle formulas can be summarized as below, which are given as this one. Okay, sine alpha over 2 equals plus minus square root of 1 minus cosine alpha over 2. Okay, sine alpha over 2 equals plus minus square root of 1 minus cosine alpha over 2. Right? Cosine beta, cosine alpha over 2 equals plus minus square root of 1 plus cosine alpha over 2. Half angle, right? And tangent alpha over 2 is going to be plus minus square root of 1 minus cosine alpha, sorry. 1 plus cosine alpha. All right, 1 minus and plus. Okay, I believe it should be what? It should be plus minus here. Okay. Well, you need to determine the sign, or rather, it depends on the quadrant. Okay, so here for these two, is that going to be the same? I do not think so. Okay, sine alpha is 2, and bottom one plus that is 2. Yes, these are good. All right, these are good. Okay, so we have these equations. All right, so these equations for tangent gives this one plus cosine, 1 minus cosine over sine. Right, they are going to be the same. Okay, so note the half angle formulas are represented or preceded by a plus minus sign. This does not mean both the positive and negative expressions are valid. Rather, it depends on the quadrant of in which alpha over 2 terminates. All right, terminates. So you need to decide the alpha over 2 where it terminates. Right. So given alpha. Okay, so these are the 3 half angle formulas. That by its name, we know where to find the sine, cosine, and tangent of what? Half of the angle, right? So if alpha is given, what is sine alpha over 2? What is cosine alpha over 2? What is tangent alpha over 2? Right? So we're going to use these formulas to find those ones. But the sign here, you got to determine the sign by identifying the quadrant of alpha over 2. Okay, so we'll show by an example here. Okay, consider this one. All right, Nick.
Find sine 15 degrees using a half angle formula.
Very good. All right, so we are trying to find the sine 15 degrees. Now you see that this is not a special angle, right? It's not a special angle. So how can we find sine 15 degrees? Now using the half triangle formula, we see that sine alpha over 2, if alpha is what, 30 degrees, right? Then 15 degree equals alpha over 2, right? So therefore we have sine by the half angle formulas. We have what? Sine 15 degree equals, now you got to determine 15 degree is in quadrant what?
1.
Quadrant 1. So sine is positive. Yes. Sine is positive. So we are going to just use positive, right? So it equals positive square root of what? Right? So by the formula, 1 minus cosine alpha over 2. So 1 minus cosine alpha, cosine what? 30 degree, yes, over 2. Now then this one equals square root of 1 minus cosine 30 is what?
Square root of 3 over 2.
Yep, okay, and over 2. So using the calculator, we can find this value, right? So what is going to be that? So square root in the parentheses 1 minus square root of 3 over 2. Close the parentheses, divide by 2. What did you get?
0.2588.
2588. Very good. That's what we have. Right? See what we did, right? So 15 is not a special angle. However, we can use the half angle formula to find this, right? So using the formula, sine 15 degree equals the half angle formula. Because 15 is in the first quadrant, it's positive, so we take the positive, right? It's positive square root of this one. Okay.
I have a question.
Yep.
Where did we get 30 degrees?
Oh,
Alpha equals 30.
well, you see that we want to find sine 15, right?
Mm-hmm.
Now, if we want to use the half angle formula, that means f over 2 is 15, right? So,
okay. Yeah, I just saw it. Yeah.
Yeah. So therefore, alpha, if we let alpha is 30, then 15 degrees is just half over 2, right? Therefore, we know sine alpha over 2 equals this one here. Now that's 15 degree. Alpha over 2 is 15, so alpha is going to be 30, right? So that's why.
Okay. Yeah, I get it.
Okay, very good. Now let's consider. Oh, it's already 11. Okay, all right. We got to stop here, and there will be a quiz and also homework. Okay, I'll see you guys in tomorrow. No, next week actually. Okay.
Right.
See you.
Everyone.
How